All right, so I think this is one of the most confusing questions in chapter 15. So I'm going to attempt to work through it and kind of explain it at the same time. So the question reads, in werewolves, hypothetically, so it doesn't really matter if this is we can just pretend that these are humans, right? The pointy ear allele P are dominant over the round ear allele P. All right, so what does that mean? I'm going to use the letters A because P is stupid because they look similar. So we know that A is our dominant, okay? And we know that uppercase A is our dominant, meaning pointy ears, lowercase a is round, and that is our recessive, okay? That's our recessive, that's what we're looking at, okay? The gene for ear shape is on the X chromosome, okay? So that's the important thing, is that this gene is on the X chromosome, all right? Now, remember, the X chromosome is larger than the Y chromosome. Females have two X chromosomes. Male has an X and a Y. This is another problem that I did earlier. And just remember, X chromosome, your daughters get an X from the mom and dad, right? But the son only gets an X chromosome from his mom. So let's keep that in mind, okay? So the problem continues, and that is what it means by sex determination in werewolves is the same as for other humans, all right? A certain female werewolf has pointy ears even though her father had round ears. What percentage of her sons will have round ears if she mates with a werewolf with round ears? Okay, so let's start with the female. A certain female werewolf has pointy ears. So what does that mean? Pointy ears is our dominant allele, okay? For her to have pointy ears, she can have two potential things. Now, this is mom. And this is who we're talking about here. Now, for her to have pointy ears, she can either have homozygous dominant, she can either be AA, or she can also be heterozygous dominant, I guess is what you would say, right? Either one of these, she's going to have pointy ears. How do we know which one she has? Okay. And we can look and we see that they give us a clue and it says her father had round ears. Okay. So if her father had round ears, which is the recessive, he had to have lowercase a, right? Any other combination, and this we can pretend just for a second. So we're about to mate her with her dad, but we're gonna for a second, this is her father, okay? Now, it's on the X gene, and she got an X from her dad and an X from her mom, okay? If her dad had round ears, he had to be a lowercase a, okay, on his X and Y. Any other combination, even though, and that's the thing, it says it's on the X, which is a little confusing in terms of a Punnett square. I don't really understand in terms of a male for this, what would happen. I guess the Y chromosome is potentially blank. If this is only on X, potentially this is blank. I'm not really sure. I don't really know how that works. But anyway, we know that she has a recessive X, okay? So we're going to erase this and erase this. So we know that she is this because her dad did not have pointy ears, okay? All right, so we're doing good. We have this for mom. For dad, however, she mates with a werewolf with round ears. So that's easy, right? We know round ears he's going to have a lowercase a. Be right back. Okay, I'm back. Because this is on an X, we can start to kind of fill out this Punnett square here, right? So, when mom has, we're going to put daughters on the left here because they get X's. So, daughter 1, mom is giving her X's to everybody. And up here, pointy ears, pointy ears, round ears, pointy ears, round ears. Okay. For dad, wait, I'm sorry. Oh, hold on. Did that wrong. Okay, right. She's just dispersing this to these offspring, okay? And just keep in mind that these are sons and these are daughters. Whoops, hold on, reversed it. XY. Sons. Oh, that's cool. Didn't know you could do that. Daughters. Okay. So that's mom. So now let's do dad. Throw him into the mix here. He is throwing his X here and his X here. And his Y here and his Y here. Now Y, it doesn't matter because, you know, I think the sons are going to get whatever this X is, you know. He's pointy. He's pointy. He's round. It really depends on what X chromosome that they get, right? For this one, for the daughters, this is going to be a lowercase a, and this is going to be a lowercase a, okay? So that's our Punnett square. If you prefer a actual square, we can kind of cross it like this. Okay, this is our Punnett square. So if we want to fill out who has what, this daughter, because she has an uppercase A, is pointy. This son, where he wrote is pointy. This daughter is round. That looks okay. I don't know if I did this exactly correctly, but keep in mind, I don't know what I was about to say. This remembers dad. This is all the information we should need. So the question reads, oh, picture disappeared. What percentage of her sons will have round ears? Okay, now we're looking at her sons. What percentage of them will have round ears? Well, from what I see, 50%, right? This is a 1-to-1 here. For every one dominant, she's going to have one recessive based on all the information we have. So the answer should be 50%. We're going to put that on to mastering here, and that's the right answer. The female werewolf must be heterozygous because her father has round ears. Each of her sons has a 50% chance of inheriting the round allele. Now, this is the incredibly long way that we could have done this. I could not understand sex-linked alleles and everything. But now I do, because I painstakingly did 2 problems to just visually see how everything works. So hopefully that is helpful for you.